Hi guys, you're going to learn 5 small tips in Python coding data analysis. How to have hand-drawn comic style plots. Normally, assume that you want to plot a histogram. So this is the code that you use. And normally, you use plt.show. But what if you want the plot more handy and more comic? Use plt.xkcd or plt.style.use. Either of them is enough. And then use plt.show. Wow, you can see the plot. It's so handy and comic, it's so nice and friendly. Next slide. How to create a 2D histogram. Assume that you have random variables. I use normal distribution, and then you want to plot the histogram of them. Okay, this is the code. But what if I have 2D array and I want the histogram in 2D? So this is how I made a 2D random variables. Just the same code as above, but the size is different. So this is 2D, and now I use hist 2D instead of hist. Now I have the 2D dimension, 2 dimension of histogram that which you can see it here. These are x values and these are y values. So this is the code. Next tip. How to deal with NaN data in datasets. What if we want to remove them? What if we want to replace the NaN data with a value such as 0? And what if we want to use the average of that value or average of that column? If you want to delete these rows, either of these codes is good, it works. The first one, just drop the rows that have the NaN data, and the second one, first detect the rows with NaN data, remove them from the dataset, and we have the new dataset which contains all data except the NaN values. We remove the NaN data using these codes. What if you want to replace them with 0 or other values? Just fill na with 0 in place is true. Instead of 0, you can use any other value that you are interested. And what if we want to replace it with the mean of that column? Assume that the column average, this column is column 3, and we want to use the average of column 3. So we just replace, instead of this code we had fill na, instead of 0 we use data underline df, which is the name of my dataset, and the column 3, which is the name of this column. Dot mean, so dot mean gives me the mean value. The first tip, if you want to use linear regression, is it necessary to add a constant to our dataset? And will it improve the performance of the linear regression? Yeah, we will see. This is the linear regression. Y is beta 0 plus beta 1 x plus noise. Now, if I use stats model, in the stats model, here is our data set. The stats model does not consider the beta 0, which is the constant value. So we should add a new column to our data set with constant values, 1 to any values, not important, but it should be constant. So I use this code to add the constant column to my data set, and then I apply the linear regression on it, or LS. But if I use a scalar method, there is no need to add this column, the constant column, because the model handles the constant value by itself. And the last tip, how to remove the tails of data as part of data cleaning. Assume that I want to remove these tails. What should I do? One method is to reevaluate the data that are below the lower quantile, I mean 0.05, to the value of the quantile 0.05. So in this part of the data, I will reevaluate these values in the red box to the value of the quantile 0.05, and also do the same with the values data that are above the quantile 0.95. So I will reevaluate these values to the data in the red box to the value of the data, which is the quantile of 0.97. To do this, I use the clip code, which I define the lower data by quantile 0.05, the upper quantile by 0.95. And in this case, I can reevaluate these data, and I can almost get rid of these long tails. If you wonder how many data are reevaluated, we can count these values. First, we define a new data set or the same data set. We can use it, and we can detect the values that are in the red boxes using this code, and then finding the len of this data set. Here, then we can find out the number of values that are the number of data that are revalued. Good luck!